Johnstown itself is a small little town, medium-sized city east of Pittsburgh, about an hour and a half over in between the valleys of two mountains over there. They were a thriving community until all the power and the steel and everything else went out, and the coal. So they're a little bit downtrodden, but the plant is fairly new. It was built in 1985. The main plant, and it's a 14 MGD facility, conventional treatment plant. They have a secondary plant, a 5 MGD RO plant that was built probably 10 years ago, but that feeds another area of their network. Johnstown being a fairly decent-sized city at one point in the middle of nowhere, basically. They were the largest facility around, so they kind of tied into a lot of other locations. Their furthest point of application is probably like 35 miles from the plant. So they go from the valley up back over the mountain, back over into Ligonier as their furthest customer. But the plant itself is permitted for 14 MGD. It averages about 6.5 to 7 MGD on a daily basis, with peak demand in summer coming up to about 10 MGD. Hold on, there's this. Okay. The plant, as I said, it peaks out about 10 MGD in the summer. It serves actually about 28,000 customers is what they have now. The plant, as I said before, is a conventional treatment plant, which means that it has the normal rapid mix tanks coming in, flocculation, direct filtration, and then chlorination. Their filter beds, they have actually eight dual media filters that they run. And basically in this application, the reason we started talking to them is they have surface water. They have 3 reservoirs around the area there, 2 that feed the Riverside plant, and in that they have to do lime softening and pH adjustment, and then post pH adjustment after the filters. The way they do that, the way the plant was set up when it was built in 1985, was with, excuse me, 1 second here, was with 3 BIF dry feeders. The BIF feeders that were put in there are very, very common in the Northeast here, in the Midwest. A lot of the plants that use lime softening or lime pH adjustment with hydrated lime, they have some type of old feeder. The BIF company was very, very big back in those days, about 30, 40 years from now. And they put in a lot of these plants, along with a lot of W&T pumps were also put in at the time. Kind of like the W&T Series 44 pumps, the BIF went out of business. They're no longer around. They don't manufacture anything anymore. So this original equipment that was put in 30 plus years ago now, they're having issues getting parts. That's one of their main things that brought up the opportunity. All the other stuff that was going on with the stuff, they learned to live with for 30 years. It's commonplace to them, the way it was. But not being able to keep parts really pushed them over the edge on this. So just knowing a plant has BIF feeders, that in itself is a very good indicator that they're going to need to replace those eventually. Because if they're using them, they're going to break down and they're not going to have parts. Johnstown has 3 of these feeders feeding lime, 1 for pre-filtration, 1 for post, and then the third one was there that they could do either pre or post with. So if they were working on one of the machines or something like that, they could switch to it. As time went on, they only had 2 feeders, because as things broke and as they couldn't get parts from anywhere else, they started to scavenge. And they started with the carbon feeders that were put in at the same time. All plants in the area around here were always put in with dry carbon feed and with dry hydrated lime feed, and most of the plants never used either. The ones that used them were normally on the lime. So the carbon feeder sat there for 30 years, never being used. So they scavenged both of them first. When those parts ran out, they scavenged the third BIF lime feeder. When those parts ran out, they scoured the internet looking for parts. When they finally got the last one that they could find out of a plant in Boston, they decided it was time to buy new feeders. And that kind of pushed them toward us. The other reasons that they identified these feeders and some of the wish lists that they had whenever they decided it was time to replace these was based on the constant, not getting constant feeding out of them. The main thing with that was that the operational mode of the old BIF feeders where they were basically designed so that they would be a pulse feed. So basically, when an electrical pulse came on for a certain duration, the feeder would spin at a constant speed, putting in a clump or a big lump of hydrated lime out of an 1.5 inch opening at the end of the feeder. So it'd spin the wound pigtail, spit it out, drop it down into a water mix tank, and that mix tank would run and try and get the big clump of stuff coming out, try mixed up. The feeder would turn off for 20 or 30 seconds until it got the next pulse, and then it would come on and do the same thing. The mix tanks that they were feeding into would have water jets at the bottom. What would happen, because you're dumping a whole bunch of big clump of hydrated lime in there, of this powder, it would hit the water and not mix very well because there's so much of it hitting the water at one time. Over the course of a day or a week, what would happen is the lime that did not get mixed well would settle out to the bottom of the tank, clog those water jets, build up in the bottom. So you would have to clean the tank based on that. The other thing is some of that undissolved lime would come out of the tank, spill out, which I'll show you a picture of it here in a second, come out and clump in a little T there that they were using to feed. So they would have to break the outside piping apart, shut the unit down and pull the lid off the mixed tank and clean out the mixed tank. They were taking about a 5-gallon bucket of undissolved lime out of those mixed tanks every week. So when they shut down, they'd have to get a little shovel and scoop out that lime. It was very labor intensive on that. They were spending 1.5 hours to 2 hours a week just cleaning up the units. And there were 3 units, well, 2 actually operational by the end. So they were spending a decent amount of time just cleaning up the units. The other thing that they had on that is the way those BIF feeders operated were, as I said, the auger would spin at a certain rate whenever the pulse would come on, but sometimes they need to slow that up or change it in the long run because they were getting too many pulses, they couldn't keep up with their feed. So to do that, they'd have to take a cover off of the BIF feeder, and there's a set of gearing and chains. And to change it, you have to get out the manual, look at, like, if you want to do 30 revolutions per minute or whatever, you'd have to look at what those gear and chains look like, go to the back of the unit, move the chain around or move a gear and get it all set up. They said that it took about 2 hours to change the speed on those if they needed to. So they didn't do that often, but when they needed to, it was kind of a pain in the butt. Those were the main things. The other thing was maintenance, because these were older feeders. The screws would break, they would bend. They showed me several of those wound pigtails that were bent into almost a U shape by the time they got out of there. And they had other ones that were broken in half and all that stuff. So they were having a lot of issues with that. This is a photograph of the old BIF feeder that was on there. This tank here, if you see the cursor going around it, that's the mixed tank. This is a water drain, so an overflow drain here, and this is a clean out drain so they can empty the tank whenever they shut the system down. This copper line coming in is a water line that came in and fed into the unit in the top here. On the other side, which you don't see, is another pipe that comes out just below here, comes out into a T, and then runs to this big pipe, this large pipe back here. It's just gravity fed back into that. That's the outlet of the tank. That T on the other side is what would get clogged all the time. On this tank, they had a mixer to try and mix up the lime as well as they could. The silo, they fed through silos. The silo extends through the basement and up into the room above it, where they were able to load the bags of hydrated lime into that silo from the top. A little vibrator on here to keep break any arches that we're building inside of there. There's a little butterfly valve here that they could shut. You can see the valve open here. This back window here, that's where the gearing in the chain drive is. They would have to pull this off and then change all the gearing and all that stuff on that. That's how they change the speed. Here they can look in and see the feeder and all that stuff, just a visual indicator. It's hard to see, but there's a little 1.5-inch diameter cylinder that came out. The wound pigtail came through that. It's spitting out of the end of that down into the tank, and an open hole in the top of the tank is where they fed it. You can see on this tank, you can see all the white on it, all the lime built up on it, because that's an open feed point. So with dust, and you get some of that lime dust around the room, and you can see it on the floor and all that stuff. You can see it's pretty white from all that. One of the solutions we came up here was the 405 feeder, but on some of that, which I'll talk about here, we went with a 405 to malt feeder based on the flow that they needed. They need up to about 46 pounds per hour of the material. So that put us in that size feeder. They had 5 screws in that feeder, so they were, it's a little bit more. It was definitely a change for what they saw. When they saw the feeder in person, I got a call. The guy was like, "Man, what the heck did you sell me? You sold me some industrial piece of equipment that needs to be in some steel mill, not in a little water treatment plant." They were used to that plastic-looking little feeder that they had there. They actually asked me if they could take out 2 or 3 of the screws, because they thought they only needed 1 or 2 screws in that thing. And I kind of convinced them not to do that and just use the VFD drive to change the feed rates, and they were good. The other thing that was on this that was good was that larger mix area. So we knew that the tank would be sealed so that you'd be gasketed from the bottom or feeder onto a tank, so you wouldn't have an opening there, so you wouldn't get as much lime and all that stuff out around the feeder. Challenges that we had on this, I wanted to mention, going back to this picture, this is existing. So I'm not going to be able to move that silo. I'm not going to be able to move that mixed tank. I mean, I could, but they don't want to. It's existing. They don't want to build a new stainless steel tank out of that. So I had to make sure that our feeder fit below this valve, because they wanted the feeder we replaced, it was just a brand new butterfly valve. So they just put that in. So they just bought it. So they didn't want to buy a new one. So I needed to fit it between here and here, but also so that our feeder, the outlet would be up here. So I only had actually from the top of this tank to the bottom of this to make sure our feeder fit. And it did, but there were some issues on it, and I'll show you kind of what we needed to do there. One of the things is, that's prominent, we're good at selling you the equipment, but we don't install it. So I needed to find a local fabricator or that, because there were going to be some fabrication that needed, modifications that needed done in the field. Luckily, Johnstown themselves, one, they have obviously had someone build these tanks and all that stuff for them. And the other thing is, there's a big glut of unemployed or underemployed welders and steel manufacturers in the Johnstown area. So they had their pick of finding somebody that would come in and work with them. What they did is, if you see this next picture, this is the actual install. It's not exactly the way we would design it up, but again, it had to fit into their existing space. Basically, what you have here is our feeder mounted in the same area. It fit fine in here. They had the fabricator come in and modify the tank, so instead of a small little circular opening, they had the rectangular opening in the lid of the tank that we needed. Underneath here, it's kind of hard to see, but there's a leg here, here, and here that needed to be welded onto their existing table to support the weight of our feeder, so that they could attach it to their table and not have it just supported by the silo in the top of the tank. So they were able to fit that in. They had a local fabricator do that. And the other thing is, they had this opening. Again, they just bought this valve. They did not want to replace it. Our feeder has a wide mouth, 16, I think that's a 16-inch opening on that one, 16-inch square. Well, we don't have that here. You see there's an actual plate that's on there that's fabricated with a plate with a cylinder in it so that they can attach it up to their existing bushing that was here, their sleeve, rubber sleeve they have, and then into the valve. So that fabricator did that also on site. We talked to them before they did it and told them that we would like to have a bigger opening. If it didn't work well, or if there's a lot of arch buildup or anything like that, then eventually we might need to go in and replace from here down. But they knew that going in. It actually, in the end, is working fine. There's another reason why they think it's working fine, but we were able to reuse the existing vibrator in the butterfly valve here. The tank, they cleaned it up a little bit later, so it actually now, it's not white down in that room. They did a good job on that because it's not dusting because it's sealed on the top gasketed, the bottom gasketed. When they first put it in, the top wasn't gasketed. They had that off looking at it. They opened this valve, line comes, big cloud coming out the other end. But, you know, they learned a little bit on that. So, they did good on that. The other thing that they have here is this, on this pillar over here. That is the VFD drive. So now, when the operator comes down, they don't have to worry about any of that. They can actually come down, there's a little dial in there, and they have a hertz readout on that, normally running about 11 hertz. They go down there, they can speed it up or down as they need to. It's an instantaneous change. They save the 2 to 3 hours that they were playing around with stuff. And also they have, it's not hooked up now, but they have the capability of running a 4 to 20 milliamp control to that, tied back to their SCADA up on the second floor, so they could actually adjust their flow rates without getting off their pushy little chairs they have up there. So it's all built in for that. The local fabricator, Johnstown's, as I said, a kind of depressed area, but having the fabricator come in, do 3 welded legs, take this lid off, recutting the lid, and fabricating this part, painting it, $650. What they charge them. So it was very reasonable, you know. Very reasonable way there. I don't know if we can find that everywhere, but, you know, the guy did a very good job for them. That is the actual installation. This is another picture of it. You can see a little bit better on that plate that was welded on top. You know, it's just a basic cover plate with a little stack in the middle, a little opening in the middle. When this was put in January, well, December 10, January of 11, they put it in to replace it. This one was not operational. This one was operational. They ran it. It was good. So they got approval to replace the other 2. So the other 2 have been replaced since then. So there's 3 of them there now. The carbon feeders, it's hard to see, but they're actually down this little hallway right here. There's a door. There's 2 in there. They're going to be replacing those coming up because they're the first time in 30 years think they might need to use them next year. They're doing a drawdown of their dredging and some drawdown of their 90-foot deep, billion-gallon reservoir. And they're afraid they're going to stir up a lot of stuff and get some taste and odor issues, so they want to be able to have the carbon online and ready in case they may need to turn it on. So they're going to buy 2 more units probably and may never ever use them, but they want to be prepared. But it's good because they like our feeders. Some of the challenges, as mentioned, was fitting the feeder into the existing space. It was a challenge. The first one we ever tried here in the U.S. This is the first installation, the first time we did one of these feeder retrofits into silos, so we weren't sure what to expect. I was told by somebody else, "Oh, no problem, man. Just give them this, and you know, well, it's done." I didn't trust them. I'm really hesitant about the sizing and the spacing and all that requirement, but it worked out great because of that local fabricator. Being able to use existing valve and arch breaker, that was a challenge, and then making sure the changes on the dissolver lid, somebody was able to do that. And we were able to do those changes thanks to the local field fabricator and do that in the field. Because we couldn't have done it here. It would have been just too, it couldn't have been done well here. We needed to be done in the field to be able to use those existing. we were building a complete new tank and complete, from the tank up, we probably could have done that here, but fitting it in between the two out in the field, we needed to work with someone locally. So on the benefits on this, of course, the first thing is they reduced and we knew this is one of the things we wanted was to be able to reduce their downtime on feeders and be able to help not worry about repairs and finding parts and all that stuff like that. So that was easy to accomplish. Our new feeder replaced an old one that no one makes anymore and hardly any parts out there. Fairly simple. The third one on the list, that instantaneous feed rate changes, that was the other main thing that they wanted. They wanted to be able to control this, be able to change it, be able to tie it into their SCADA system, which they couldn't do with chains and gears. So they were able to do that because they upgraded all their electrical stuff this past year. So those are the two things that we tried to get. A couple other things up here, we didn't know that we were going to be able to do that, but it was like one of those added benefits. Because the way that feeder has 5 screws across it, instead of an 1.5 inch auger that was coming out and dumping clumps of feed down in there, the way those feeders work, it's basically, when you watch it, you can barely see those augers moving, turning. You don't see them move hardly at all. They're moving so slow. But you get a cascade effect across that whole sweeping area. So you'll see a little bit of the lines like cascading down onto the right side, then the middle, and then the left, and it cascades across that. Just like sprinkling it down into the water across that whole 12-inch opening, instead of lump feeding it through one little 1.5 inch opening. So because we were able to spread it out more and sprinkle it in there, it was able to wet better and mix better.
How much do they get on the bottom of the tank now?
They don't get any on the bottom of the tank. They don't clean out the bottom. They haven't. I think they cleaned out once since 2011, January of 11. They've cleaned out one time versus once a month. The pipe on the outside, they take it apart once a month just to make sure. So they haven't cleaned it at all. But they take it apart once a month just to make sure it doesn't clog because of the problems they've had. So that was, 3 hours or an hour and a half per machine. So that's, 4.5 hours a week just on that they saved. Sometimes in the summer they had to do it twice a week. They had to clean out the tanks. So they saved at least 7 to 8 hours easy just on that. The other thing they saved on is when they make their changes to their flow rates or anything like that, and also on downtime because these things were breaking down so often. So they saved at least 1 man day per week. And that's a lot for a small plant. And the guy that was doing the changes was their maintenance, one of their big maintenance operators, one of their main guys that was doing the changes. So it's like, if he had to do 8 hours a week, he lost 1 day a week just maintaining 3 little dry feeders. So to get that back was very beneficial for them also. With all that, they were able to buy a couple other units. And the other nice thing is being able to tie it back into their SCADA. That's one of the things that they just finally started looking at this year. But those were the main benefits for them. With that, that's basically all I have. If there's any other questions or so, I guess I'll turn it over to Jim and he can coordinate.
Yeah, questions for anyone online. If you would use the GoToMeeting toolbar, there's a questions section there, and then we can read those and have Dan address those. Some of the things we reviewed at our earlier presentation, we found that with them trialing, in a sense, that first unit or giving it a chance, they did purchase it, but after they liked it so much, the specs for the other 2 units that they were going to buy were written directly around that. So there was no way that we were not going to have those sales. And in the future, the activated carbon units that they'll buy, we expect to be the same way. So, just that one trial, we have at least 2 dry feed opportunities in that one plant. And that's just to name, a couple of the dry chemicals that we have opportunities with these units. So there's an entire list. If you're not aware of what those can do, please be in contact with us. We can get those lists to you. If you have a dry feed opportunity, definitely ask us if we have something to offer for it. I would pretty much say that the answer would be yes with the Tomo units. They can do pretty much any dry chemical feed. Any questions here in the room?
One of the things I wanted to mention is looking at these applications in the Midwest, where we do a lot of lime softening or pH adjustment of surface water, knowing that when you walk into a plant, you see the VIF feeders or those old feeders that are out of, just them themselves, knowing that there are issues with getting parts, knowing that that company's no longer around, which most of our sales guys know, that's a key to start focusing and asking questions about those feeders. A lot of plants have feeders that they're not using, but that's one of the key things, just knowing that's going to be there and to look for it.
We do have one question online so far. It's asking, is the line feed based on a flow meter? Is it flow proportional?
Yeah, they know their plan, as I said, is normally about 6.5 MGD. They have a 25 million gallon storage tanks that they maintain. So they do have a flow meter coming in, so they run those things knowing they're about 6.5 MGD. When they need to change it, if they need to fill those tanks, more water's been pulled out of the storage tanks, and they need to up the plant output, then they do go down there and manually, well, they were going down manually changing it, but they will be adjusting that via the SCADA. But it is based on flow through the plant.
Okay. Thanks, Dan. Anyone else online has a question? Okay. One other thing Mr. Weber asked in the earlier one, the list value for one of those feeders that now we have, you can see at least the opportunity for 5 in this plant, roughly.
Yeah, it was about $15,000 for the feeder in the VFD is what the cost was on that. That again did not include any startup because I was going to go out there, being the very first one out there. I was going to go out and do startup myself. They got the feeders right before Christmas. He gave me a call on the 23rd, said, I got it, maybe right after Christmas, you can come out and do startup. And I told him, yeah, no problem. He called me back the Christmas Eve and said, hey, we started it up ourselves yesterday. It took about an hour. We're good to go. Don't worry about it.
We're getting some feedback from our AE group. They're saying that the price is up slightly. It's between 18 to 20,000. So it's a very nice opportunity, and we think that once they get one of the units, they will like it. In fact, Johnstown Water has offered to be a voice for us, a reference for us. So if you do have someone that's interested but they're a little bit skeptical, they can call Johnstown Water and talk to them. They have since written a white paper for us. So, they're very pleased with the unit and have offered their services to us just to spread the word about it.
Yeah, and Paul at Johnstown Water is very, very enthusiastic about being the very first one of these feeders that was sold and retrofitted into the United States. So he's very proud about that, taking the risk of doing it and seeing the great reward, and he wants to tout that out there as much as he can.
Yeah, we said earlier that we were not sure that he would be so proud and happy if it had gone bad, but the fact that it's gone so well for him, we think he's very pleased about that.